Right, lesson 6.6c, the last of the properties of logarithms, solving equations involving logarithms. So reviewing our properties of logarithms, product property, we see this addition involving two logarithms with the same base, right? Log base b on both sides of that plus sign there. I can rewrite that as one logarithm, but I multiply the m and n value right here. So if you see, and you're trying to solve a logarithm and you see addition in there, you may consider the product property. And then similarly with the quotient property, you have two logarithms with the same base being subtracted. You can combine those into one logarithm where you divide the values. And then finally, to apply either of these, you have to have, right, log base of something, and then plus or minus, right, log base of something. You can't have that coefficient out front, so we can use the power property to move this n as an exponent to the m value right here, like that. So those are what we're going to be using today as we try to solve some more logarithms. The problems in this slideshow are also part of the assignment. So as I work through these, I'm going to, for the most part, just do the odd problems because the even ones are part of the assignment. So getting started here, log base 10 of 27 equals log base 10 of 3 times log base 10 of x. And my go-to is always to look and see, can I evaluate anything? Right, so could I put this into my calculator, right? Log of 27 divided by log of 10, or just log of 27 would work in this case. And I can't evaluate it, but I get this, right? This 1.431 goes on forever decimal. So that's not real helpful when I'm trying to solve an equation. So the next thing I'm going to look at is, because I have this log base 10 of 27 on the left side of the equal sign, I am going to look at, do I see this same log base 10 over on the right side? And I do. However, I have this this exponent, or this coefficient out in front, this 3, that is preventing me from just solving the values. So I need to use the power property here. That allows me to take this 3 and turn it into an exponent on the x, right? So if I use the power property there, I get log base 10 of 27 is equal to log base 10 of x to the third. Okay, so now these both are log 10 and log 10 of something. So I can drop down the 27 equal to the x to the third. So now I'm very close to being done. I could take the cubic root of both sides, or I could just take each side to the 1/3 power. Same concept, right? Going to give you the same result. Taking things to that 1/3 power, probably a little easier if you need to use the calculator. Some people would recognize the cubic root of 27 being 3, but if you need to calculator that, you could take 27 and then to the 1/3 power using the caret, making sure you put parentheses around, especially the 1/3, but I just always put them around both sides of the caret, right? Both values on the numbers on both sides of the caret, right? So we get an answer here of x equals 3. You could plug that back in if you wanted to confirm that what you've done is correct. So in number 2, just to kind of get you started, right, I see the log 7 in both of these. However, they have a number out in front. So I can use that power property here. I'm just going to use it twice, once on the left side, once on the right side. So I'm going to have log base 7 of 4 to the third equals log base 7 of b squared. And then I can solve it from there. Looking at problem number 3, I have log base 4 of 5 plus log base 4 of x equals log base 4 of 60. And I have lots of log base 4, but this addition right here is holding me up from solving just by dropping the values that I'm taking the logarithm of. So that addition right there tells me I can use the product property, right? So I can take the two values here that I am taking log base 4 of, and the product property says that you can multiply those, right? So I'm going to put the 5 times x in one logarithm. So log base 4 of 5 times x equals log base 4 of 60. And now I have log base 4 of a value equals log base 4 of a value. So I can bring down the 5 times x, or 5x, equals 60. And then I can divide out the 5. Right? So my x would be 12. Okay, and number 4, it's going to go similarly. You're going to use that product property because we have that addition there. On number 5, I see subtraction, right? Log base 5 of 2 different things being subtracted. Helps if I turn on my pen. Right? I see that subtraction, which tells me I'm going to use the quotient property. I could have tried to evaluate this part here first, but I don't think that would give me anything real helpful. So I am just going to go right into quotient property. And that says that those 2 logarithms with the same base that are being subtracted, I can take these values here and divide them. Okay, so then that'll still be equal to log base 5 of 1. Right now I have log base 5 and log base 5 on both sides. So I can bring down the values that I'm taking the logarithm of. Since it's an equation, right, those 2 things have to be equal. So the y over 8 has to be equal to the 1. And then I would finish this out by solving for y, right? I move the 8 over, right? Multiply both sides by 8. So I get a solution here of y equals 8. And number 6 will be solved in the same way using that quotient property. 7 and 8, right? On this one we see addition. So that's going to be the product property. However, right, I have log 9 here, and I have log 9. So I have log 9, log 9, log 9, but I have this 2 out in front here. So before I can use the product property, I need to use the power property. And so I'm going to take this 2, and I'm going to make it an exponent on the 5. Right, so this is going to become a 5 squared. So I'll have log base 9 of 4 plus log base 9 of 5 squared, which is 25, equals log base 9 of w. Now I can apply that product property, right? Because I have log base 9 on everything in my equation. So product property says log base 9 of 4 times 25 is equal to log base 9 of w. Now that they're both log base 9 of something, I can bring down the 4 times 25, which I'm going to simplify to 100, in the W, right? So W equals 100. I could check these out with my calculator to make sure that everything works out and that I don't get any invalid solutions. But because everything's positive, I should be okay. So for number 8, when you work number 8, you're going to do the same thing, right? Except it's going to be quotient property because we have this subtraction here. But before you can start, you're going to have to use the power property here, and then you can set up your quotient. Finishing out, we're starting these out in exponential form. And number 9, we could solve. We could rewrite 243 as 3 to a power. But that's not going to work for any of these other problems, like number 12, 4 to the 5k equals 37. I cannot rewrite 37 as a power of 4. And even if I change both of the bases, I cannot write 37 as a power of 2 using whole numbers. So that strategy is not going to be super effective. So what I'm going to look at is changing the form. So I am going to label out my b to the y equals x. And on this one, it gets a little confusing because here, my y value in terms of that relationship between exponential and logarithmic forms is actually the variable x, which is also used in the relationship. So that's why I would always just quickly write down your labels right above what you're working on. So then the other part of that relationship is log base b of x equals y. So that when I go to fill this in, right, I can say, okay, it's log base b. Well, b right here is 3 of x, which is right here, the 243, equals y, which is this x from my original problem. Right, so that's the confusing part, where y is equal to x, or one of the variables in our relationship is a different variable. Right, so now I am left with just x equals this log base 3 of 243, and I'm just going to go and plug that into my calculator. Now this one will give me a whole number, but the rest of them will not. So log of 243 divided by log of 3, I get an answer of 5, right? So right there, 3 to the 5th power is equal to 243. So number 10 will be solved in the same way. I would label things out. For 11 and 12, there is an extra step because my my exponent here is a 3b, not just a single variable. But we're going to start the same way. We're going to, right, b to the y power equals x, and then log base b of x equals y. And then I'm going to sub in. So log of b, which I see right here, is 5. So log base 5 of x, which is this 106, equals y, which is 3b. So I have something that I can evaluate here in the calculator. So let's go ahead and do that. Log of 106 divided by log of 5, using that change of base property, log a big over log a little, right? So this is going to be 2.898 equals 3b. In reality, I would probably not even write this step down on my paper, because I know to get b by itself, right, I'm going to have to divide all of this by 3. So I would just go right back to the calculator, right? I have the log base 5 of 106 already in there, and then I can just turn around and hit the divide by 3, and it takes that log, divides it by 3 for me, and I get point 0.966. Right? Number 12, be the same way. Label things out, change the form, and then evaluate the logarithm and solve for k. So that is it for logarithmic properties and solving logarithmic equations.